students, and welcome again to eMaths with Mr. Meshak Ngige. Kindly remember to subscribe, share, and also comment how these lessons are being helpful to you. So today we're going to be checking something on our Maclaurin series, and that is the Knec revision. So kindly keep locked as we check one or two questions that come in the Knec past papers and how to handle those particular questions. And we have a particular first question that is from Knec past paper, electrical engineering. So evaluate the Maclaurin's expansion for the function sin squared x, and hence evaluate the limit or the integral from 0 to 1 of the function that you've been given there, dx. So now solution. So we know, first of all, we have to write the expansion. So we know that our series will be given by f of naught plus the first derivative with respect to 0, then x plus second derivative with respect to then x squared, then we have 2 factorial, and so on and so forth. So this one continues, okay? This one is a series. So you have to remember always, it is f naught x to power 0, f, the first derivative x, second derivative x squared, third derivative x cubed over 3 factorial, and so on and so forth. So now we have a function which is given by, so f of x is given by sine squared of x. Now from this point, what you need to know about trigonometric functions, this one can also be written as sine x and what? Sine x, then you have squared, all together. So therefore, if you replace your f0, okay, so it will be sine of 0, which is 0, then squared, which is just 0. So we'll have 0. So in this case, we are looking for 3 non-zero terms. We are looking for around 3 non-zero. So you have, when you replace your fx, then you replace your x being 0, then you find our firsts will be 0. We have our first derivative given by. So now, when differentiating this function here, this function shall be differentiated by what we call chain rule, where you let your function which is inside the bracket to become u, then your new y will give you u, then squared, your new f of x, which is called also y. Then you differentiate the function with respect to u with respect to x, then you have y with respect to u. But now I'm going to show you a very short way of doing it, which is just the same thing, but in just a different way. Now what we do here, we say, assuming this part inside the bracket is a polynomial. Now the normal way of differentiating a polynomial is drop the power, reduce the power by 1. So that is what we're going to do here. We shall drop the power, then reduce the power by 1. So we have the sine of x. So we reduce this one by 1, it will be to power 1. So it will just become sine of x. Then you multiply by the derivative inside of the function inside the bracket. So what will, when you differentiate sine of x, what do you get? You get the cosine of x. So therefore this one gives us 2 sine of x cosine of x. You can try doing that in the long way of product rule. You'll get one and the same thing. Now this function here, if you remember from trigonometry, there's something called compound angles, not compound angles but double angles. This is represented by this function here, sine of 2x. Sine of 2x can be rewritten in this form. So instead of having two functions multiplied together, we can put them as one by double angles, which is just represented by the sine of what? Sine of x. So therefore our first derivative here will be the sine of x. Therefore f prime of with respect to 0, what do we get? So sine of 0 times 2, which is sine of 0, which just gives us what? Just gives us 0. Then we get now our second derivative. Now differentiate this function. So when you differentiate sine, you get cos. So remember, you remove the 2 outside, then cosine of 2x. Therefore our prime 0. So it will be 2 cosine of 0. Cosine of 0 is 1. So 1 times 2 gives us 2. So you shall have that. Then you have the third derivative, and the third here. So again, differentiate this function. So we'll have, remove the 2. So we'll have 4. But now when you differentiate sine, you get, when you differentiate cos, you get negative sine. So we'll have negative here, all together. So we'll have negative 4 because you have these 2 outside, then sine of 2x. And therefore f triple prime So the aspect that you have a sine function here, this just becomes a 0 because the sine of 0 will just give you 0. So we have that. Then the fourth derivative, differentiate this function again, remove 2 outside, so we'll have -8. When you differentiate sine, you get positive of cos, so it remains to be negative here. Then you have cosine of 2x. Since you have so f 1 over 4, the fourth derivative, so cosine of 0 is 1 because you'll have 2 times 0, which is 0. So cos of 0 is 1. 1 times -8 gives us -8. Remember, again, we are still looking for the 3 non-zero terms. So again, we have the sixth derivative, so the fifth, sorry, of x. We shall have, differentiate this one, will have -16. Now, let's see. When you differentiate cos, you get negative of sine, and we have another negative here, so it becomes what? It becomes positive. Right, together. Differentiate this one gives you a negative of sine, therefore, and we have another negative here. But when you remove the 2, it becomes 16, then you have sine of 2x, and the aspect that you have a sine, this one becomes 0. So 0. And remember, we are looking for 3 non-zero terms. And now you can check the derivative that follows from there and see what it gives us. So we have, now differentiating a function of sine, we get positive of course, so f6 we shall have, so remove the 2 outside, we'll have 32, then sine becomes cosine of 2x. Now when that one is 0, 6 will give us what? So we have cos of 0 is 1, 1 times 32 gives us what? 32. And that one now gives us the 3 non-zero terms by the end of the day. So we have, the first one is 2, the second is -8, our third one is what? Is 32. Now let us write, what is the Maclaurin series for this particular function. Therefore, our f of x, which is our sine series, and just sine squared x, we shall have. So remember, it is the first term, so it is this term here, then x to power 0, so just this term, so we shall have 0 plus, then again 0, then x, then plus, so we have 2, then x squared. Remember, the powers of x increases as we go on, then plus, then only 0, x cubed to power 3 factorial, plus, let me write it here, we have now -8, so it will be -8 x, so it is to power 3, so we have to power 4 over 4 factorial, then plus, we have, the next one is 0, x to power 5 over 5 factorial, plus, then you have 32, then you have x to power 6 over 6 factorial. So therefore, in short, we shall have our term, so sine squared x will be given by, this one is 0, this one is 0, so this one is 2, 2 factorial is 2, so you remain with what? Remain with x squared, this one is 0, this one is -8 over 4 factorial. Remember, 4 factorial is 4 times 3 times 2. So 4 times 2 is there, so which is basically an 8, so it will remain with -1 over 3 x to power 4. Then you have 32 over 6 factorial. Remember again that 6 factorial is the same as 6 times 5 times 4 times 3 times 2 times 1. So we can have this. So you can say this one is this times 4 times 3 times 2 times 1. So you can try and simplify with the term in the numerator. So you can start with 2, and 2 gives us what? Gives us 16. Then you can have 4, and 4 gives us 4. Then you can have 2, 2, 2, 3. So therefore our term, the numerator, will be plus 2 all over, this one is 15, 15 times 3 is 45 x to power 6. Therefore, your expansion for the sine squared x using the Maclaurin's series or expansion will basically be given by x squared minus a third x to power 4 plus 2 over 45 x to power 6. So now, we now check the derivative for this. So we shall have the integral. We know our expansion is given by that. We already found that. Then we have sine squared of x over root of x, then dx. So now the first thing we do is to rewrite, okay? So 0 to 1, our sine squared x expansion is given by this in terms of x, okay? So it is x squared minus a third x plus 2 over 45 x to the power 6, then all over a root of x can be written as x to the power what? Power a half. Then you have the dx. Now again, simplifying this further, we can take our x to the power half in the numerator. So we have x squared minus a third x, this one is to the power 4, plus 2 over 45 x to the power 6, so we can bracket that. Then our x, since it is a positive power, goes up, becomes a negative power, then you have dx. So now, from the laws of indices, we shall multiply this term with every term inside here. So therefore we shall have from 0 to 1. Now, remember, when you are multiplying numbers with the same base, you do what to the powers? You add the powers. So if I multiply x to the power negative a half times x to the power half, what I'm saying is the base and the base is the same. So you just do what? You add the powers. So we shall have x 2 minus a half, which gives us 3 over 2, that is 1.5. So 3 over 2. Then minus a third x 4 minus a half, that is 3.5, which is 7 over 2, then plus 2 over 45 x, then you have 5.5, that is 11 over 2, right? Then dx. So now our function has simplified to become that. So what you do now from this point is just now integrate the function that you already have there. So therefore shall have, now we have x. Now we know you increase the power by 1, divide by the new power. So increase the power by 1, divide by the new power. So what we only have there, so x, that is 3.5 plus 1. Okay, no, sorry, that is 1.5 plus 1 gives you 2.5, which is 5 over 2. So we have x 5 over 2 minus a third x. Then okay, sorry for that, it is increase the power by 1, divide by the new power. So it is x 5 over 2 divide by 5 over 2 minus, we have a third x, increase it by 1 again, becomes, so this one is 7 over 2, it becomes 11 over 2. Is it 11? No, 9 over 2. 9 over 2 divide by the new power, then plus 2 over 45, then x, that is 11 over 2, then plus 1 gives you 13 over 2, then divide by 13 over 2. Okay, that is the law of integration. Increase the power by 1, divide by the new power. Now, since this number here is a fraction, these are fractions, fraction, and fraction, we can always reciprocate this term here. 1 divided by 5 over 2 is the same as 2 over 5, right, together. These are simple algebra, so we shall have 2 over 5 x to the power 5 over 2, still simplifying, okay. Then again reciprocate this, so we shall have 2 over 27 x to the power 9 over 2, then plus, so reciprocate this one again will be 4 over, that will give us what, 45 times 13 x to the power 13 over 2 from 0 to 1. So we have those terms. So therefore we now replace our limits. Our limits are from 0 to 1. So the upper limit replaces here, then the lower limit. Now for the lower limit, remember where you have an x, you replace with 0. So when you replace your lower limit, all the terms will be zeros, because 0 multiplied by 0 multiplied by this, 0 multiplied by that will just be 0. Then x is 1. 1 to any power is 1. 1 to any power is 1. 1 to any power is 1. So therefore we shall just remain with the fractions here. 2 over 5 minus 2 over 27 plus 4 over 485. Now when you add up all that, what do you get? You'll get this number here. So confirm if your particular value be given as 0.333. And that is how you solve the question using the Maclaurin's expansion. And this is a very good question because it warrants you around 10 to 12 marks. So if you know how to go about it, then you have saved yourself some very good marks. So let us check another question, another example on Knec past paper that is from the Maclaurin's expansion.